Hi, everybody. Today what we're going to go through is the topic that you can see at the top of your page. So we're going to cover the concept of slope. Now, this is a very big concept for us this year. In fact, it's so big that, my guess is, if you were to sit in a grade 10 class and think back to what you talked about in grade 9, probably a large component of what you were going to remember is going to go, oh, well, we talked about slope all the time. Okay, slope is a big concept for us. So what I put on that page is just a little bit of info regarding it. Slope measures the steepness of a line. So we're going to start to talk about is how steep is something. We're going to start to compare steepnesses. We're going to start to look at how we deal with that in a very abstract way. So I put a few pictures on down here, but I also wanted to go through and say, there are a lot of different terms that are used to refer to the incline that we may see in an object. Sometimes you'll actually use the word incline. Mathematically, we call that slope. If you were to go in an international setting, like anybody who's studying IB, they're going to call that gradient. Quite often, we can think of those things as the angle, but I'm hoping that for the most part, when we talk about slope, we actually just think about the steepness or the slant of an object. Okay, what we're going to do is we're going to get into some concepts for today on slope. Slope for us is such a big topic that we're going to break it up into two parts. So we're going to have slope 1 as the first part of the day and then slope 2 as the second topic. Okay, let's jump right in with slope. So what you'll see then next on your page is to study the slope of a line. So now we're talking about mathematically. For us to examine slope, I'd really like you to underline what I've underlined in red. I'm just going to highlight it here. That what we see is we always examine a graph moving left to right. I just want you to notice real quickly that if I was to put a line down like this, then we have two possible terms that we could describe that slope as a slope that's moving positive or a slope that's moving negative. And as we start to think about those, then we think about, the words like rising, and I hope that most people would equate rising with positive, versus a line that is falling and that being matched up with something like a negative. One of the issues that we get is there's a lot of people who could look at that purple line and say, but isn't it doing both? And so if you notice, if I viewed that line moving left to right, then that line is rising. However, if I started at that line and looked at it from right to left, then it's falling. And so if we were going to try to talk about those things, that is a line moving upward, or is a line moving downward, we have to be consistent. And so the whole world got together, the whole mathematical world, and said, okay, the way we're always going to look at every line is we always move left to right. Always. And so that means that when I look at that purple line, I do not think of it in green terms. I can only think of it in blue terms. As I move left to right, that line is moving upward, and therefore we would say that it has a positive slope. If we were to then see a line that was falling, then I would have to consider as I move left to right, my graph is moving downward, and therefore it has a negative slope. Okay, being able to identify positive and negative slopes are your first big idea. Okay, let's keep going. Okay, so what you see at the bottom of that page then is I've given you a graph. On the right, you have a grid set of axes, and I have put a number of line segments on that set of axes. So what I want to do then is I want to go through and I want to examine the slope of each one of those line segments. So let's fill in the gaps as we go. The first thing that I can take a peek at, the line segments in the diagram are A, B, C, D, E, F, G, H, and now I notice that I have some other line segments. So I have AB is right there. I have CD is right there. I have EF is there. I have GH is there. Well, I'm missing two other line segments. And so if I was to just erase all of that highlight so we can write in there, then I also have line segment IJ and line segment KL. There we go. Okay, I'm going to get rid of all that purple. Now we can take a look at problem A. Besides line segment IJ, which line segment is the steepest? Now take a look at B. Which line segments have a positive slope? Now take a look at problem C. Which line segments have a negative slope? And then we get a bunch of other information as we proceed down. Okay, so what I want you to do is I want you to try to answer questions A, B, and C. Okay, that's what we're going to answer, A, B, and C. Okay, I want you to pause it now. Give it a shot. Okay, let's see if we matched up. So, besides line segment IJ, which line segment is the steepest? And hopefully we selected line segment EF. For question B, which line segments have a positive slope? Well, we know positive slopes, negative slopes are all determined by moving left to right. So, if I go through, which line segments have a positive slope? Well, there's a line segment that was rising to the right, and I think that's it. So I have line segments AB and CD. Okay, which line segments have a negative slope? So now I need line segments that are falling to the right. And that would be line segment EF, EF, and KL. There we go. So if we matched up, then I'm going to argue to you, you probably have a pretty good sense of what's a positive and negative slope. Okay, let's look at the next section of problems. A horizontal line segment has a slope that is 0. So for question D, which line segments have a slope of 0? I want you to pause it and answer that now. Okay, hopefully we can see that only one line segment is horizontal, and that's that one right there. And so we should have had an answer of line segment GH. Okay. A vertical line segment has a slope that is undefined. So for E, which of these line segments has a slope that is undefined? I almost don't even think that we need a whole lot of time on that one. We should be pretty good to be able to say, well, there's my vertical line, and so that one is going to be line segment IJ. And there we go. So hopefully we match up a little bit. We actually even got some new ideas in there about, well, what does it mean to have a slope of 0? Or what does it mean to have a slope that's undefined? Okay, we're going to keep going with this type of topic. Okay, let's turn over the page. So what you have then is a picture. Off on the right side, I have given you a number of line segments again. The only difference is I've taken away the grid. So what I need you to do then is trust your eyes a little bit more, which is always a dangerous thing in math. But let's trust our eyes a little bit more. And then look at all the line segments that I've listed in red on the left. And now what I need you to do is for each one of those line segments, I want you to check off the box that matches best with that answer. So for instance, on line segment EF, does that have a positive slope, a negative slope, or neither? Line segment GH, positive, negative, and so on. Okay, I want you to try it for every single one of those line segments. And then we'll come back and we see if we match up. Okay, so let's pause it now. Okay, we're back. So let's take a peek pretty quick. Line segment EF, hopefully we found, was negative. Because as I move left to right, it is falling. Okay, we take a peek. Line segment GH. GH is positive because it is rising left to right. Line segment IT, well, if I look at that, you know what? That thing looks vertical, which means it is neither rising nor falling. Line segment QR. QR is falling to the right, so a negative slope. Line segment SL is positive because it is rising to the right. Line segment MN, well, MN looks pretty much horizontal, which means it is neither. And then line segment UP, it's pretty flat, but I still see that it is rising to the right. Okay, hopefully we match up, and we did pretty well. Again, all we're doing is talking about steepness of a line, and really all we focused in on is direction as of now. Now what I want to do is I want to start to break down, well, once we've seen that a slope is positive, can we start to compare positive slopes to each other? Can we start to compare negative slopes with each other? And so on. Okay, let's jump into that next section. You're going to see a question right in that middle of that page that just asks, which is steeper? So between those two line segments, line segment A, B, and C, D, which one of those is steeper? Now, I'm hoping that everybody could simply answer the question, line segment AB is steeper. But now what I want you to consider is that red question off on the side. Yeah, but why is it steeper? And we need to have a better idea, a better answer than just, well, it is, like you can tell. So can you think of how you could prove to me, or what would be some reasoning that would enable somebody to, comparatively speaking, and objectively say why something was steeper than something else? Okay, I want you to consider that. It's going to take some time. So let's pause the video and you try to come up with an answer to that why question. Okay, pause it now. Okay, we're back. Now, maybe we still don't have an answer to that, or maybe we do have an answer. There is something that I also want you to know. That the height of the first line segment, AB, is the same as the height of the second line segment, CD. Like, I created those line segments, and when I did, I ensured that the height, if I was to come straight down here, compared to the height, is exactly the same. So let's just take a peek at what our answer to that why question was. And if there was any part where that question was like, but it's taller, we've got to get rid of that. They both have the same height. So let's try to rethink our answer. Pause it now if you need some more time. Okay, we're back. So, one of the things that I want us to consider as we examine this is a relationship between what you see in the green dotted lines and the blue dotted lines. And I would hope that for us to examine when something was steeper doesn't just take into account how tall something is. It actually also has to take into account those green dotted lines. And so what we could end up saying, even though it's imperfect, but to answer the why question of why is AB steeper than CD, we could end up saying something along the lines of that it rises faster than CD. If both of those blue lines are the same length, then look how long it took for CD to rise to that height versus AB. It only took AB this amount of time to go all the way from A up to B. However, it took C that amount of time to go from C all the way up to D. That really what we're talking about when we talk about slope is how long does it take to get to a certain height. That really what we're looking at is the idea of rising and how long it takes to rise. Well, to examine the rise means we have to look at this vertical component that you see in blue versus this horizontal component that you see in green. So, can we amend what we wrote in red then? That really I don't like the rises faster than CD. Like, it's the right idea, but can we be a little more descriptive? What could I put down for my reason for why? Really, it's the change in height from one end of the line segment to the other. So from A to B or from C to D, comma, over a horizontal distance. And that's my green portion of my diagrams. That is shorter. Really, I like that as a description better. That the change in height from A to B over the horizontal distance is shorter than the change in height from C to D over that horizontal distance. I think that's getting us to what is slope. That's our meaning. But now when we go to talk about it mathematically, we've got some new terminology to address. So let's take a look at the bottom of that page. On the bottom, you have this diagram where I've put on a line. And so you'll see that line on my diagram highlighted in green. There is my line. Well, if we want to talk about slope then as being the way the height changes over a horizontal distance, then what we actually have is some terminology for that. The way the height changes is talking about a vertical distance. And you'll notice that that vertical distance is referred to as the rise. I'm going to highlight that on the diagram. You'll also see then that we were talking about over what horizontal distance. The horizontal distance mathematically is referred to as the run. And I'm going to highlight that on the diagram. And so when we talk about the slope of a line, then really what we're going to talk about is the way that your rise, compares to your run. And so really what we have then in our rise is our vertical distance, and what we have in our run is our horizontal distance. And so when we talk about slope, the whole world got together and said, okay, so let's have a value that we can use, a rating system, how we can calculate all of these different slopes that exist in the world. And well, if we can assign them all a number, then we can start to compare which lines are steeper to others. How do we arrive at that value? We calculate the rise over the run. Now, I often joke, you guys need to know that slope is rise over run so much that that has to become instinct for us. So what I mean by that is, like, I want you rolling over in the middle of the night, waking up out of dreams, wonderful dreams, but you rolling over in the middle of the night, waking up going, slope is rise over run. Like, I would want that if I was to pass you walking in the hallway and I just yelled at you, hey, what's slope? You should be able to just go rise over run. Immediately. We need to have that in our back pocket. Okay, now that we've discussed what slope is and how to calculate it, let's actually work our way through making some calculations on slope and seeing a few issues that may arise. So, as you take a look at the top of the next page, I've just given you 4 diagrams. And what we're going to do is we're going to work our way through calculating the slope on each. So, as we're trying to drill into our heads, okay, what is slope? Well, the easiest way to drill it in is to write it down all the time. So maybe my first line then is slope is rise over run. Okay, now I'm going to calculate my slope. Well, as I take a look at that diagram, I notice that my rise was 15, and I notice that my run, my horizontal, was 11. And there you go. You are done. Now, you're sitting in a math class. Mathematicians want to be exact. So you're going to give me an answer of 15/11ths, and you are perfectly happy with that. That fraction is fully reduced. It is in perfectly good form. You're sitting in a science class. They're going to want you to calculate that and round that off because they're going to be talking about an application of something. You need to know, when you are sitting in a math class, if I ever ask you for slope, you give an exact value. There we go. Okay, let's jump into B. Okay, I have to calculate slope, so I'm going to drill it in. Slope equals rise over run. Remember, we want to drill it in. Okay, now we're going to calculate the slope of that stairwell. Okay, I want to go through this one 2 different ways because I'm going to bet that I would have a lot of people that would tell me that they had a rise of 16 and a run of 20, and they would be incorrect. And it's not because that fraction can be reduced. No. It's because we didn't take something into account. Look back at your diagram for A. Is that a rising slope or a falling slope? Well, if we look at the slope of that skateboard ramp, it is rising to the right. So it makes sense that we have a positive slope. Take a look at the slope of the stairwell. Is that positive or negative? I think we can see our mistake. Now, as I said, though, I want to show us two different ways to be able to go through. So let's take a look at the first way. If I was to go through and examine the slope on that, well, I can start on the left and move to the right through a rise and run movement. Okay, for me to get from the top of the stairs to the bottom of the stairs, I would have to go down. And look at what direction my arrow just went. Down. And so down would mean that my rise is actually negative 16. I went down. Okay, now I have my run, and I have a run of 20. And notice that if you were to take negative 16 divided by 20, that's going to give us a negative value. And if I reduce my fraction, then I notice that 4 goes into both of those, and I can reduce that to negative 4/5. Okay, but I also want to show you another way to be able to get to that slope. I want you to take a peek at us going through and dealing with that the opposite way, because I don't want anybody to think that they have to follow those red arrows. No, you don't. I want you to imagine that we were going to go through and we were going to solve the green arrows. That is, maybe I started at the bottom of my stairs and I went back up to the top. Well, how do I get there? Well, I have to go to the left. And I want you to think about your number line and think about what types of numbers are to the left. Now I would have to go up. And you start to think about going up and what type of numbers up would represent. And maybe we can see our alternate case. So we could have also had that maybe my rise was positive 16 because I went up 16. But my run would be a negative 20 because I was going to the left, and on my number line, the left is negative. Now, the nice part is, reduce your green fraction, and you're still going to come to negative 4/5. So the nice part is, there's no pressure. Like, we're not going to make a mistake if we choose to view a diagram a certain way. But we do have to be conscious of it. I think you are really showing your maturity with the topic if you were to just simply say, okay, I'm going to calculate my slope on B. I know slope is rise over run, so I have a 16 over 20, but I know that my slope is going down to the right, which means it has to be a negative slope. If we came in on the gold, then I think we're really showing our maturity. The only problem is a lot of people are going to forget about the negative. Okay, you choose how you think you should best work through those problems. Okay, let's jump into C. Okay, why am I talking about C? Well, it's not because we know or need practice with the fact that slope is equal to rise over run. We know that cold. However, when we go through to sub in our values, we're now going to say that that has a rise of 7 and a run of 5.5. Our problem is we can't have a fraction that has decimals in it. So now we have to eliminate the decimal in that fraction. Okay, how can we do it? Well, I think the easiest way is to multiply top and bottom both by 10, or move your decimal place 1 to the right. And now that we've created a fraction, that fraction can be reduced. We go ahead and reduce it. Divide 70 by 5 and we get 14. Divide 55 by 5, we get 11. There is your perfect solution. We like 14/11. So be careful if one of your measurements has a decimal in it. Okay, I'm going to leave you guys with D. I want you to try D on your own. Okay, pause it now. Okay, so hopefully I see that slope is equal to rise over run. My rise in this case is 0.5. My run in this case is 7. However, one of those has to be negative because we see that that ramp is falling to the right. There we go. Now, I don't know how you choose to change that. Maybe we change that into 5/70ths and then we divide top and bottom both by 5. Or maybe we just go, hey, I know that 0.5 is 1/2, so if I take 1/2 and I divide it by 7, I get 1/14. Any way you came up with that, I think we're good. So hopefully that gives us a little bit of practice now at seeing some of the issues that can pop up when we're asked to determine slope. Okay, let's take a look at the bottom of the page. On the bottom of that page, you have a grid. On that grid, you've got 4 line segments. You notice I've labeled those in the chart on the right. What we're going to do is we're going to calculate the slope for each one of those. So I want to walk through the slope of AB together, and then I'm going to leave you with GH, CD, and EF. Okay, we take a look at slope, and I've even put for you up in that table, slope is rise over run. Okay, so I look up at the line segment AB, and I notice A is in that location, the blue location, and I have to move to point B, the other blue dot. So how do I get there? Well, I have a feeling that most people would say, okay, slope is rise over run. So my slope would then be going down 1 unit. So I see that I have a rise of -1. And then my run would be going to the right 1, 2, 3, 4, 5 units. And so I have a slope of -1/5. However, there are so many different ways to get there. Like maybe you take a look at A and you think the green route, that you go across 5 and down 1. Well, no worries. Then you just would have said like -1/5. We just have to make sure that the rise goes on top and the run goes on the bottom. But maybe we went the opposite way. Like maybe we looked at it and we said, I'm going from B to A. So I went backwards 5 and then I went up 1. And so we could have written down our 1 over -5. We just know that that is horrible form because a negative denominator doesn't make sense. So then move that up to the top or write that as a whole fraction that's all negative. There you go. So for any one of those, we should be good. Okay, I'm going to erase off all those arrows. And what I want you to do now is to come up with the slope of GH, CD, and EF. Okay, pause it now. Now, okay, we're back. So if I'm just going to come up with the slope of GH, then I know that my slope is rise over run. So how do I get from G to H? Well, I have to go down that distance. And now I have to calculate how far is that. Well, yes, you can count squares and go like 1, 2, 3, 4, but that becomes really tedious. Instead, maybe we look and we see, well, if I look over here, I'm at a y-coordinate of 5. So to get back to the x-axis, I have to move down 5. Well, now, to get down to this point at the very bottom, I have to go down another 5. Because I look over at point H and I notice that it's at 5. And so, if I put together those two 5s, then I can tell that I went down 10. Okay, how many across did I go? Well, if I do the same thing and I look up, I was at -4, and then I have to go across. I look up to 1, so across 4 and another 1, that gets me a run of 5. Yes, you can go through and you can count squares, and that will always get you there. But as those points get really far apart, counting 4, 5, 6, 7, 800, 9, and so on, it just gets so tedious. But we can determine that. I have a rise of -10, I have a run of 5. When I simplify that, because I can divide that out, I get to -2. Please don't write down -2/1. You know that I'm going to put a boo on your page if you do that. Okay. We're going to get a little confirmation on CD. I'm just going to erase everything I wrote for GH. Okay, on CD, I know that my slope, well, my rise is going to take me up 1, 2, 3. It's a nice short distance, so maybe I count those out. And then my run is going to take me, well, from my x-axis all the way over to an x-coordinate of 6, so my run becomes 6. Well, a fraction of 3/6 I can reduce, and there's my 1/2. There we go. Now you take a look at EF, and I got a little bit more. They're farther apart again, so maybe I try to shortcut that, and I say, okay, well, my slope, I go up 3 to get to my x-axis, and then I go up another 5, so that's an 8. I go across 2, and so my slope then is going to be a rise of 8 over a run of 2, and that gives me a slope of 4. Okay, hopefully that stuff matches up. Now, a couple things that I want to get back to, and we're going to leave it on these last two things. I'm going to pick just a little spot on my graph. And so let's say I take that top right corner where we've got a little empty space, and I'm going to create a new line segment. I'm going to put on a line segment that runs from here over to here, and I'd like you to draw it on there as well. Now we go FG or EF. How about I go G, H, A, B, C, D, E, F, G, H. How about I go line segment I, J? Okay. Could we calculate the slope of IJ? Now, I'm hoping that I have everybody that just remembers. Like, I would love it if we do. I doubt that we do, but I would love it if we do. That we all know that the slope of IJ is going to be 0. I hope. Because way back on the very first page, we addressed that the slope of horizontal lines is 0. But I think we now have enough at our disposal that we can see why it's 0. So if I was to calculate my slope, okay, what's the rise of line segment IJ? And do we notice that since it is horizontal, there is no rise? I don't go up any units from I to get to J. And so what that becomes then is a rise of 0, but I can calculate my run. Like my run would be over 1, 2, 3, 4, 5 lines. So I could say then that my run was 5. And then if I was to ask you, well, what's 0 divided by 5? Then we should be good that we get 0. Now, can we draw the conclusion then that for any horizontal line, we're going to get a slope of 0? I'm just going to change something in that calculation. Like, let's imagine that IJ was not exactly where it was. Like, let's make point J right here. Well, can you now see that our rise is still 0, but our run became 2? Well, what's 0 divided by 2? 0. Do you notice that regardless of how long line segment ij is, I will always have a rise of 0 divided by some number? And what's 0 divided by any number that's not 0? It's equal to 0. And so maybe we get a little confirmation now as to why a horizontal line segment has a slope of 0. Okay, we're going to do the same thing as what we just did. We're going to kind of draw another line segment. And I have this kind of like big open section in the middle. I'm going to put a point here and a point here, and I'm going to create that line segment. Well, we just did ij, so let's go KL. And I want to calculate the slope of that. Okay, so what's the slope of that line? Well, how do we calculate slope? It's rise over run. And that line absolutely has a rise. Okay, how many units? Well, we go up 1, 2, 3, 4, 5, 6, 7, 8. So maybe we say that that has a rise of 8. Because I thought that I went up. But do you notice how that line segment's vertical? We could have just as easily said that, yeah, but aren't I going down 8? And so maybe we have a rise of negative 8. Here's where I'm going to say to you, either one is correct. Because this is where the wrinkle comes in. What is my run? And so I'm just going to change some colors to be a little consistent with our note. And I hope that you see that our run is 0 this time. I didn't move across at all to go from K to L. Point K is on top of L. And so what happens when we take a number and we divide it by 0? Well, then we get undefined. And notice, for everything that we did before, I could change the length of KL. Like I could say that KL was here and like all the way up to the top. Notice that we would have a different rise in this case. So we would have a different number as our rise. However, our run would not change. I still have a run of 0. And so anytime I'm dividing by 0, then I get my undefined. So I would hope that anytime you saw a horizontal line, you would go slope of 0. And that anytime you saw a vertical line, you would go undefined. But we do have the means to be able to calculate it as well. Okay, that gets us to the end of part 1 on slope. I think we've done a lot of good stuff in this. We introduced what the concept of slope was, we recognized steepness, we understand what slope is, and now we know how to calculate it on a diagram as well as on a grid. Okay, your job now, jump in and get some practice. Okay, good luck.